Good morning. Sorry I'm a little bit late. My Windows desktop, my Windows computer updated itself just a few minutes ago, and I had to just sit and wait for it to finish its update. Okay, that was kind of unexpected. Okay, so you should see the desktop and hear me. Is everything seem okay now?
Yep.
Okay, thanks. Great. Okay, all right. So we're gonna. Okay, the exam will take me a little while to grade. Let's see. So let's see. Where are we? Hmm. Oh, let's see. This should. There. Oh, I'm sorry. Okay, I forgot to refresh the page. Okay, so the exam from last week will take a little while to grade. I hope it'll be done by next week. Okay, so we're going to continue with these topics here that'll finish with array. I think we'll finish arrays today. We have a little bit more to talk about arrays, and then we'll start another topic either on Thursday or on Thursday we should be starting another topic. Or there should be a new reading assignment. I have to update the reading assignment here. Okay, so we left off. Here's the problem we want to look at on arrays. Okay, so we want to solve the problem of searching an array. So we kind of started this at the beginning uh, last week before the exam. Okay, so let me open Dr. Java. Let's open in Dr. Java first. The thing to think about that we've seen before is let me actually go here. Open the Java visualizer. Something we've seen before is the index of method in the string class. So if I have a string like I'll just do A, B, C, D, E, F, G. Okay, I can on that method I can call the index of method and ask what's the index of X in that string. Well, so I could ask for what's the index of, say, E in that string. Okay, and I'll get it back an integer answer. I'll call it N. Okay, now the way to remember, strings are like arrays. In fact, strings kind of are arrays. And what we have is we have index 0. The letters in the string have index 0, 1, 2, 3, 4, 5, 6. Okay. And 7 is the length of the string. The string has 1, 2, 3, 4, 5, 6, 7 characters. They're numbered from 1 through 6. So index 7 is actually the last. Index 7 isn't a character in the string. That's the length of the string. Okay. And strings literally can be thought of as an array of characters. Yeah, they act exactly as if they were an array of characters. Okay. Now I could also ask for uh, int m equals. I'll use the same string A, B, C, D, E, F, G. The index of X. Okay, X is not in the string. Okay, if I visualize this, okay, I got back 4 for E. You can see here the character E is below the 4. Okay, and I got back -1 for X. This is the way index of says I couldn't find what you're looking for. If you want, you can think of -1 as being. You can kind of think of the -1 as being this index over here that's at the beginning, before index. So if you think of it one way is that index 7 is not in the array, it's at the far right end, And index -1 is not in the string either. It's at the beginning. So index 1 sort of marks the beginning over here, and index 7 marks the end over here. Okay, and this is the length, and this is the index they use to mean we couldn't find something. It's not a valid index. So this is a way of saying, here's a number back, but it's not a number you can use. It's a number that denotes that we couldn't find the letter you were looking for. They could have returned the answer 7 too. But the reason they didn't do that was, suppose that I did this one. Suppose my string was suppose I did something like, if I did this string, okay, and I wanted the index of x. Okay, well, in this string, the appropriate the indices are 0. The indices are 0, 1, 2, 3, 4, 5, 6, 7, and then okay, -1 is on this end, but the last one is 8. Okay. Okay. So now I get a different answer here. I would, well, oh, forgot the of. I froze one. Yeah. The reason I give the answer -1 is because, see, then I would get the same answer here. If they were using this as to say, oh, I couldn't find the list, I ran off the end of the string and I couldn't find you what you're looking for, so your index is this one here. Then they'd give one answer there and a different answer here. But they want to give the same answer. So they use what's on this end of the string, -1. Okay. So it's a little bit clever. They could use the number on either end of the string as saying, well, I ran off the end of the string and I couldn't find what you're looking for. But instead of giving the maximum index, the length, they return the -1. Okay. It really could, even this number here, it's the length of the array. So it is in a sense the same thing as this. 7 is the length of this string. 8 is the length of this string. So in a sense, they are returning the same idea, but it's a different value. But they didn't want to do that. So they returned the number that's over on this end. Okay, the length of the thing that would be off this end of the string. Okay, now we want to do something similar. We want to, now this is searching an array of characters looking for something. Okay, we're going to write our own method that searches an array of integers looking for something. Okay, so we want to do something similar to this with array of integers. Okay, so, oops. Okay, here's the example. Okay, so right now I've got 4 different ways of writing it. So I'm going to just take one of them and copy it up into the Java visualizer. So there's a whole bunch of ways of doing it, but to make it a little bit easier to read, I'll just take one of these. Okay, so I'm going to take that one and put it up on the Java visualizer. Okay, and let's see, I need to end that and end that. Okay, now I'm going to fill the array with random numbers and then look for something in the array. So I want this thing here, so I could start off by putting a bunch of well, this thing will put random numbers in the array. So I create this random number generator. Okay, I create an object of type random so I can generate random number generators. Here's an array of 10. It's empty right now. So I called it random ints, but this creates an array filled with zeros. It's wrong to say it's empty. It fills an array, it creates an array, but the default value in the array is all zeros. Okay. Now here would be a loop that loops through the array, and every slot in the array gets a random number between 1 and 100. Okay. Remember, this gives you a random number between 0 and 99. And then I add 1 to it to make it a random number between 1 and 100. Okay. Then, okay, I'm going to look for the number 50 in the middle. Okay. So did I get the number 50? Now, I have a 1 in chance. I have only 10 numbers, and I generated 100 random numbers between 1 and 100. I'm sorry, I generated 10 random numbers between 1 and 100. So I have a 1 in 10 chance of getting any one number. So I have only a 1 in 10 chance of actually getting this number here. Okay. If I made this like if I made these the random numbers between 1 and 50, I'd have a much higher chance now because there's fewer numbers to choose from. So I'd have more likelihood to get the number I was looking for, to get that number 50. Okay, but from 1 to 100, yeah, there's only a chance of 1 in 10 instead of 1 in 5. Okay, so I may not get. So I'm more likely to get this, and I'm more likely to get that answer. Now here's how it's going to work. I'm going to look for this number. So this is the number I'm looking for. Clearly, what I'm going to do is I'm going to step through the array and compare everything in an array to n. Okay. So I'm going to now, where is going to be my guess of where this number is in the array? Okay. Just like over here, I want to return where it is in the array. If I find it, I return where it is. If I don't find it, I return -1. Okay. So I start off by guessing that I'm not going to find it. Okay, so there's my initial guess that I don't find it. Okay, then I start at the beginning of the array and I step all the way through the array. Okay, if the ith entry is equal to n, I change my guess to I because I found the n. I found n at I. So where in the array it is I. Okay, and then I print out the answer. Okay. Now, this is actually not going to act like this one does. Okay, it's going to act like this one in this case, but it's not going to act like this in another case. We'll see in a second. Okay, so let's just watch it. Okay, so I create the random number generator, create the array of 10 zeros. Okay, then loop through and loop through and fill it in with random numbers. Okay, notice there's no 50 in there. Okay. Okay, so now I'm done filling it in. Okay, now that's the number I'm looking for. Okay, now create another. Okay, there's my guess that I'm guessing that I'm not going to find it. That I guess that all the time. So there, I can see that number's that's actually going to be the final answer, but the code has to figure that out. But I'm guessing that I'm just not going to find it. I could have guessed almost any. Well, this is the best guess to make because if I don't find it, I don't have to change my answer. So this I could have guessed anything here. I could have guessed a 0. But then if I hadn't found it, I'd have to change my final answer to be -1 to say I didn't find it. Okay, so this is actually the easiest initial guess is to guess I don't find it. So this is a good initial guess. It's not, I don't have to guess that I don't find it. I could guess that I found it at 0. But this is a good, and it's better to do this initial guess. Guess that you don't find it, and then if you get to the end and you never found it, this thing holds the right answer. Okay, now start going through the array. Okay, at this point, I is 0, so I'm checking 29. Okay, and notice that this was false, so I just went back right up to here. Okay, now I'm going to increment I to 1. Check that I haven't gone to the end of the array. Now check this slot. I'm checking this number against n. Okay, and it's going to be false. So I'm going to go back up to line 27. Okay, now I'm going to increment I. Now I'm going to check that I haven't got to the end of the array yet. So I spend 2 clicks on this line here because I went to here first and then I go to here. Okay. Now check the third number. Okay. False. Okay. And this is just going to keep going back and forth. Okay. So I just checked I7, I8, I9. Okay. Now I finished the array. Okay. And I'm going to get the answer that the index of 50 is -1. Just like here, the answer is -1 to mean that it wasn't found. Like, well, here, the answer is -1 to mean it wasn't found. Okay. All right. Now, let's make it so we find the number we want, because there's something kind of funny about this. Okay. So go back here. Now, to make it so that we find the number we want, let's make these random numbers between, say, 1 and 20. Okay. Okay. So make these random numbers between 1 and 20 and look for the number 5 instead of 50. Okay. Now, if I generate 10 numbers between 1 and 20, I have a pretty good chance of getting a 5. Okay. Okay. If I have 10 numbers between 1 and 20, I have a 50-50 chance. Okay. So I have a 50-50 chance of getting a number. So let's just try executing this. And I didn't get the number I wanted. So I'm going to try it again. Actually, I want to guarantee that I get the number. So I'm going to just generate 10 numbers between 1 and 10. I'm going to go ahead and just generate 10 numbers between 1 and 10. Okay, so I'm almost guaranteed to get the number I'm looking for. Okay. So here's my 10 numbers. And I didn't get a 5. Okay. Okay. I did not get, notice I generate 10 numbers between 1 and 10 and I didn't get a 5. So let's try it again. Okay. Okay, I've got 2 5s. Actually, I got 3 5s. Okay. So I got 3 5s in the answer. So think about what's this code going to do? Okay. It's going to be looking through the array for the number 5. It's going to start off by guessing that it's not going to find it. Then when it finds it, it updates where. But so when it finds it here, where will be 0. Then when it finds it here, where will be 5. Then when it finds it here, where will be 6. So the final answer is going to be the last place it found the 5. So let's watch. So, okay, so we're looking for 5. We guess that we're not going to find it. And then we start stepping through the array. Okay. Well, right away, we find it in slot 0. So where is going to be 0? So we found a 5 at slot 0, but then we keep going through the array. Okay. We don't find one in slot 1. We don't find one in slot 2. We don't find one in slot 3. Don't find one in slot 4. Okay. Now we get to slot 5, and there's another 5 in there. So now the where is going to get updated to 5. Okay, so see now where is updated to 5, because that's the last 5 we found. And then continue on. And then there's another 5 at 6. So where gets updated now to 6. And that's the last place where there's a 5. So now we step through the rest of the array. Okay. And now we print out that index of 5 is 6. Now that's unindex of 5. There are more than one 5, and we got the last one. Now, if you go over here to the way index of works, let me just do an example here. Let me do the string there's a string. And let me find the index of A. Well, find the index of B. There's two B's in the string, one near the beginning and one near the end. So there's two B's, okay? Okay. This index of gives you the index of the first one it finds. So if there's two B's, it only tells you the first one, okay? So if we visualize this, whoops, I forgot. Oh, I have to change this number here. I'll make a Q this time. Okay. Okay. So 0, 1. See, it found it at slot 1. Okay. So it doesn't look, it doesn't give, if you want the last one, there's a method for that. Okay. So for example, let me do this one. Let me do this again. There is a last index of, okay. Now the last index of B is over here, okay. And now, see, there's an index 1 is the first and index 5 is the last, okay. So that's the first and last index of B. So in a sense, our method over here is acting like last index of, okay. It's finding the last, but what if we want the first index? Okay, so we've got code that mimics the last index of, okay, and what we actually wanted was the first index of, like this one. So the idea is, what can we do to change this? Okay, okay. So this one finds the last index. Okay, now if we go back over here, see, notice it said that we're finding it said in the comment that we're finding the last index where the thing is found. So the comment even said that we're finding the last index. Here's a trick for finding the first index. What we do is we change the code and we put this special command in there. It's a new word in the Java language called break. Okay. So what break does, what I'm gonna do is I'm gonna just make a copy of this so we can play with the copy. Well, So we can leave the other one there and play with the copy. Okay. So this is version 2. Okay. This one finds the first. Okay. What we do is when we found what we're looking for, we break out of the loop. So that's what the break command means. It means you can only use break if you're somewhere inside of a loop. Okay. And if you're anywhere inside of a loop, break just jumps from here to the outside of the loop. Okay. It just stops the loop in its tracks and it just jumps from here to that line there. So it would jump from the break to the, see, notice it doesn't jump out of the if statement. It jumps out of the if statement and out of the for loop itself. The if statement's inside of the for loop. This thing breaks out of both, well, out of the if statement and out of the for loop and goes to the next line of code at the end of just after the for loop. Okay, right. So as soon as we find the first instance of n, we jump out of the loop. Okay. Okay. So let's see that work. Now we have to hope that we get multiple versions of 5. So let's try it. Let's see. There's 1, 5. Okay, there's my 2 5s. Okay. Now notice that one of them, by coincidence, ended up at the very end of the loop. Okay, and one sort of towards the middle. Okay. So, but this one's supposed to find the first 5. So it'll go through here, and what's it going to do? we're looking for 5 in this array, okay? We make the guess that we don't find it, so we're guessing that we're not going to find it. Then we start going through the array, okay? At slot 0, we don't find a 5, okay? At slot 1, we don't find a 5, okay? Slot 2, we don't find a 5, okay? Now, here we're at slot well, not quite yet. At slot 3, we're going to find a 5, okay? So now I have I equals 3. This one's going to be equal to that one. So I'm going to set where equal to 3. Now here's the break. The break's going to jump me from line 32 to line 35. Okay, see? And then index of 5 is 3. Okay, so I found the first one. Okay. Now, if we wanted to, we can go back and redo this one. Okay, so let me show you a way to redo this one. Okay, we're going to find the last, but in a different way. We're going to use an idea from here to find a last a different way. So I'm going to call this 1A because it's a slightly different version of finding last. But now, in this case, if there were multiple 5s, you step through the array finding all of them and quit when you found the last one. But if you want the last one, why not work from the right end of the array to the left? Why don't we just move from right to left in the array? So let's go here and start with index I being random ints.length -1. Start at the right end of the array. Keep going until we get the index I equal to 0. We'll keep going while the index is strictly greater than 0. And subtract 1 from the index. So start at the, let's see. Okay, start with the index being at the end of the array. As long as the index is greater than, or that should be greater than or equal to 0, I keep stepping through the array. Okay, I don't need this line anymore. Okay, I don't need that anymore. Okay, well, I do need it, but I don't need to initialize it to -1. It doesn't really matter what I initialize it to. In fact, I can leave it like this. Okay, I don't even need to make an initial guess. Okay, now what happens is if I never find oh no, I'm sorry, I still need to make the guess that, because if I never find what I'm looking for, I never do this. So I'm still going to guess that it's at -1, because if the number is never in the array, I'll get all the way to the end and never do this assignment. So this thing will never be updated. So it needs to be at -1 if I never find it. Okay, so just like before, it still needs to be initialized to -1 so that if I never find it, it just keeps the value that it had at the beginning. Okay, all right. So I'm going to start at the right end, decrease until I get to the beginning of the array, and look through at every number. Now, the advantage of this is if I have a length of, suppose I have an array of 2 billion items, and I find the number near the end, I don't have to step through the whole array. Yeah. Now, if the number is near the beginning, I will have to step through almost the whole array. But if there's multiple numbers in the array and one of them's towards the end, this will find it faster than moving from left to right. If I'm trying to find the last item, I might as well start at the right end, and then I have to now break when I find it. Okay, so I start at the right end, move to the left, and when I find it, I do a break. Okay, so let's visualize this. Here's the array. Let's see if we get more than one. Okay, now there's the 5. Okay, now there's only one 5 in there, but it's near the end. Now, instead of starting at the left end and working our way till we find that 5, we'll actually do it the more efficient way. We'll start at the right end and only take 2 steps and find it right away. So look for 5. Okay, guess that we're not going to find it. Start at the right end. Start there. Okay, there's not a 5 at slot 9. Okay, now decrease to 8. Now we're going to find a 5 at slot 8. So we find it. Where is 8? And we break out of the loop. Okay, and we're done. Okay, all right. And let's get an example where there isn't it. Let's do it again. Let's see if we we get an array that doesn't have any. Well, just go to the end. Let me try. I'm going to see if I can get one with no 5 in it. Okay, there it didn't find. Let's go back to the beginning. Okay, there's the array with no 5. Well, let's see. Oh, I haven't finished initializing it. Okay, there's an array with no 5s in it. Okay, so there's an array with no 5s in it. So now we'll see that we're gonna step our way back through the whole array. Okay, okay. So we start here at haven't started yet, index 9. So we start at index 9, and we're going to look through all these numbers, and we're going to see the index down to 8, 7, 6, 5, 4, 3, 2, 1. Okay, there's slot 1, which is a 10. It's not okay. Now here's slot 0. So I is 0. Okay, it's not there. Okay, now notice I goes to -1 because we have to make this thing false to make. Well, I'm sorry, we have to make this thing false to stop the loop. This thing has to become false. For that to become false, I has to become -1. Okay, but that drops us out of this loop where the where is -1 also. So that's kind of a funny coincidence that we quit the loop exactly when this guy is equal to this guy. Okay, so quit the loop. Okay, now notice that the I disappeared because we're out of the loop now. So if I go back, I is -1, so that makes this false. So that drops me out of the loop. When I drop out of the loop, I disappears. Okay, and then I can return. Okay, there. Now, here's even another way I could do this. I don't actually, if I'm going to step through the array backwards, I could actually do something a little bit funny. This is what I meant to do a minute ago. I don't need where. Okay. What I'll do is I'll declare I outside the loop. I'm going to declare I outside the loop. So now when I get to the end of the loop, I will still be, it won't disappear. And as we just saw, if you go through this thing and never find the number, I will end up with -1. Okay, so if in the case of stepping backwards through the array, I don't need the where variable. I can just use the I variable itself. So let's see if we can let's do another example. Let's see if we find one. Oh, oh, I forgot to. Then I changed this output to I. Okay. Oh, I'm sorry. I don't need this either. Now, I is where I found it. So I just have to break. Okay. Okay. So what I'm going to do is I'm going to erase this line, and then I'll make a comment here that I is the index of the last n that was found. Okay, I itself is where I found it. So I don't need the where variable. I can just get rid of the where altogether. Okay, it's just kind of a weird trick that I can, in this case, since I'm stepping through the array from right to left. When I hit -1, when I hits -1, that means I never found it, but that's the answer I want to give, -1. So in this kind of funny case, since I'm working my way to the left on the array, I can let I be the where. Okay, so let's see if we find a case that does that. Oh, there's one. So let's go back. Okay, here's the array. Okay, so there's no 5 in there. Okay, right. So now we're going to start working our way backwards through the array. Okay, n is 5. Start with I, 9. Okay, that's not a 5. So start going. Now I will drop to 8, then 7, 6, 5, 4. We're stepping this way. We're not finding any 5s. 2. Okay, now 1. Hey, here's the last one. We're looking for a 5 there. Okay, it's not there. So this one fails. Okay, now you're here. Now you have to drop from 0 to -1. I is -1. That finally makes this false. Okay, so we drop out of the loop because we're finished. And now I is -1, just like we wanted to be. We didn't find the number, so I just holds -1. So this is kind of a funny trick. Okay, and it works because I'm searching backwards through the array from right to left, and I'm looking for the last occurrence. So because I'm looking for the last occurrence, it's more efficient to start at the right and move to the left. And if I'm moving to the left, when I get to the end and don't find it, I'm at -1. So I don't need another number to keep track of where I found the answer. Okay, so there's kind of a quirky version. Okay, so it uses somewhat similar idea to this one. This one stepped forward through the array, and when it found what it's looking for, it breaks. This one's stepping backwards through the array. When it finds what it's looking for, it breaks. Okay, all right. Now, so there's several different ways of doing the same thing. Now, what about, okay, so this one found the last in kind of an inefficient way. This one found the last occurrence, but by stepping through the whole array, so it would find all the previous occurrences, and then it would find the last one this one actually goes through the whole array every time. See, there's no break. So this one always goes through the whole array, whether it finds the number or not. So that's not really efficient. If the array is 1,000,000,000 items long and you find a number at slot, say 1,000, you don't need to go through the rest of the array. Okay, so you want something like this that would break out of the loop. Okay, when you find what you're looking for, you might as well stop looking for it. Okay, and then if you want the last item, you can do it this way efficiently by moving through the array from right to left, breaking when you find what you're looking for. But since this one's kind of quirky, since it's moving from right to left, and when it doesn't find something, it ends up at -1, I don't need the extra variable. Okay, so in that sense, it's like this one. It breaks when it finds what it wants, but this one needs a separate variable to hold where it is because it has to think. Now, um, oh, actually, notice that when you find what you're looking for, I is where you're looking for. So why do you really need where? What if you just broke out of here with I? Okay, let's actually see if we can do that this one. Um, let's redo this one and see if we can do it without this extra variable. And we'll see that we have to be a little bit careful in this one if we don't want the extra variable. Because when we do find the number, okay, so what we're gonna do is get rid of that variable there. Okay. Now, and then make I outside of the loop. Okay. So I lives outside of the loop. So I can say I here. Okay. Now this is wrong at this point. Okay. What this will do is this will report the largest, this will report the length of the array when it doesn't find something. So let's see what happens with this one. When we don't find what we're looking for, this one will actually report the end of the array, the length of the array. Okay. So let's see. Okay, so there was oh, I'm sorry, that no, that was, let me try, see if I find one where there's no 5 in the array. Okay, that had a 5 in it. Take a few tries, I'll get one without an that one had a 5 in it. Oh, now I got a string of bad luck. Okay, see there's no 5 in there. Okay, now notice what the answer is. The answer is 10. See, it went off the end and got to index 10. Let's go back to the beginning, fill the array. Okay, so now we're going to look for 5. Now there's no 5 in the array, so we're going to look here, 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 here. Then when we get to the end of the array, we're indexed at 10, and so then we report 10. So we're going to step through the array, and we're not going to find the 5, so we're never going to break. Okay, now I is 10 because I ran off the end of the loop over here at index 10. This thing became false when I was more than the length, one more than the length. That's when this became false. But I don't want to report 10. I want to report -1. So I can kind of fix this by doing the following. I can say, I can put an if statement here. If I find out, so here's what I say, if I equals random ints dot length. So that means if I went off the edge of the array, if I went off the right, so if in fact I actually went off the right, then I'll just say I equal -1. So I'll kind of fix my answer. Okay. So I'm avoiding this extra variable. I'm not having this extra variable that was the where. Okay. But now I have to fix things a little bit. If I'm going to step from left to right and use the fact that when I go off the end of the array, that means I haven't found the number I want, then I have to check, oh, if I went off the end of the array, I didn't find the number I want, so I have to make I back to being -1. Okay, so that fixes it so that I'm reporting -1 to say n wasn't found. Okay, notice how many different variations on this there are. What part of this is just practice and seeing that you can think about code in a bunch of different ways. What's the right way to write this method? Well, this is one right way to write it. I had a right way previously where I used where, okay, and I guess that the one before it was was correct too. Okay, notice that there's more than one way to write the correct version. Okay, and there's actually a lot of different ways to write the correct version. So here now I'm looking for the first occurrence. Okay, I'm stepping through the array from left to right, looking for the first occurrence. I'm not using a where variable. I'm just using the index to tell me where it is. When I find it, the index is where it is. So if I break out, the index is where it is, except if I get to the end of the array, I don't want to report the length of the array. I want to report -1, so I have to adjust my answer if I went off the end of the array. Okay, and so that's just another way to do it. Let's see, let's find one where there's no 5. Okay, okay, right away there. Okay, no 5 in that one. Okay, okay. Now we'll see that fill the array. Okay, now step through the array, and now I'm going to step through the array all the way to the end. Never break. Okay, now I'm looking in the last slot. Okay, now I'm index 10. So I'm off the end of the array. And now that finally makes this false. So then I will, now I drop out of the for loop the right way, not by breaking, but by getting to the end of the for loop. And now I do this test. If I is the length of the array, that means I didn't find what I was looking for. So I'm going to adjust the answer to -1. And then I can report that the final answer, the index of 5 is -1, meaning it wasn't found. Okay. Notice that if you go back to over here, we actually have no idea how they wrote index of. Okay. And we have no idea how they wrote last index of too. Like, did they do this one by starting at this end of the array and moving to the left? Did they do this, or did they do this one by starting here and going to the right and then just uh, waiting till they found the, do they go through the whole string? Maybe they just go through the whole string. Same with this one. Maybe they go through the whole string. Well, for this one, they can't go through the whole string because you want the first one. So if you went through the whole string, you wouldn't want to hit that B again. But since this one is looking for, and this one, if you go from left to right, you can do last index of by going through the whole string. But if you go from right to left, you need to break when you get there. Okay, so they could do that a whole bunch of different ways, and we don't really know how they wrote it. And it doesn't really matter how they wrote it. Okay, though it does matter a little bit. Uh, if you're finding the last index and you go from left to right, you're going to go through the whole string every time. If you're finding the last index and you go from right to left, you don't have to go through the whole string when you find the number. You only go through the whole string if you don't find the letter. Okay, so in a sense, if you're finding the last occurrence, you probably should go from right to left because that makes you not go through the whole string when you fail to find it. Okay, now what about going from left to right? Okay, if you're finding the first index of, you probably don't want to go from left to right because then you'll find all of the occurrences and you only want to find the first one. So if you're going to go from left to right, you should break when you find as soon as you find the number. You're probably not going to find the first occurrence by going from right to left. They could, but that would probably be really dumb of them to go all the way through this string from right to left to find the first occurrence. That would be a very dumb way to write the method. Okay, so we've seen a bunch. Now, we've now seen a bunch of ways to write finding the first occurrence. We can find the first occurrence or the last occurrence. Finding the first or last. Well, in this case, we're finding either the first or last, depending on which one we want to find. Finding the first or last, moving from left to right or right to left. Okay. Now let's see if there was another version here. We've done. Notice that there were 4 different ones here. Okay, the first one moved from left to right, but it found the last occurrence. Okay, this one found the last one. Okay, this one moves from left to right, and it uses a break to find the first one. Okay, see what this one. Let's see if this is one we are done. Oh, this one gets rid of the extra variable. See, that's the one that gets rid of the extra variable. And this is the one that affixes. This one sort of fixes things. This is another version of how to fix. This one reports 2 different answers. Okay, this one kind of this is equivalent to our last one where it's going to, well, actually, this one's a quirky one. Notice that there's nothing in the for loop. Okay, this one, this is a funny example. Okay, let's take this one and put it in the visualizer. Okay, so what I want to do is, let's do that last one. I'm going to take this and make a copy of it in the visualizer. And now I'm going to replace this part here with that fourth solution. Okay, so this one's kind of quirky. So we want to say a little bit about this one. Probably it's not one that most programmers would even write, but it's kind of good for us to just see how this one works. Okay, right. The weird thing is it's got an empty for loop. So there's nothing inside the for loop. I mean, I could write it this way, but there's nothing inside of here. There's just a semicolon by itself. Okay, so there's nothing inside of the for loop. All the work is done here. Everything is being done in here. Okay, so the I is going to be declared outside of the loop. Okay, I starts at 0, so I'm going to move from left to right. But then I check, what if I found, see here, there's where the test for finding something is up here. Okay, so I'm using an and. If I is still less than the length of the array, and the number in the I slot is not what I'm looking for. So if I have not reached the end of the array, and I have not found what I'm looking for, do another loop. Now there's nothing in the body, so then I go, have I reached the end of the array? Have I found what I'm looking for? If I'm not at the end of the array and I'm not found what I'm looking for, I increase I again. Then I ask, have I got to the end of the array? And if I've not found what I'm looking for, so I'm not at the end of the array and I haven't found what I'm looking for, increase I. Okay. Now, if I never find what I'm looking for, I ends up being n, the length of the array. So now I could actually fix it by, I'll change it to this one. Here I wrote it as, if I is less than the length of the array, report this, otherwise report did not find. But to make it like the other ones, I'll just change it to be the other way. I'll say, if I got to the end of the array, I'll just adjust my answer to be -1. Okay, so it's a slightly, so I'll make it like all these others, that it'll report -1 when it didn't find the answer. So I'm going to report -1 when I don't find the answer. Okay, so I'm going to step through the array from left to right with an empty loop. Okay, and I'm just going to check this more complicated logic here. I haven't reached the end of the loop and I haven't found what I'm looking for, so I step to the next entry in the array. I haven't found what I'm looking for, and I haven't got to the end of the array, and I haven't found what I'm looking for. Now, if this is false, either because I got to the end of the array or I found what I'm looking for. See, if I find what I'm looking for, that makes this thing false. So I drop out of here. I don't need the break statement now. I drop out of here with the I that I want. Okay, so it's washed. So some people like this because it gets rid of this break, which is kind of funny, to just, break out of the loop. Some people think that this is easier to read. Some people think that this is easier to read. From our point of view, it's good. Both are good, and both are practice in thinking about the logic of how you write programs. Here, I'm doing the exact same thing here as I'm doing here with a different kind of logic. Here I'm stepping through the array from left to right and breaking out of the loop when I find what I want. When I find what I want, I break out of the loop. Here's another way of saying the same thing. If I don't find what I want, I stay in the loop. So if I did find what I want, I'm breaking out of the loop. Because of this and here, this is saying that if I don't find what I want, I stay in the loop. But if I do find what I want, that makes this thing false, so I break out of the loop. So it has the exact same logical effect as this, but written in a pretty different way. Okay, so visualize it. Let's see. Now let's see if we got. Well, let's just step through. Okay, fill the array up. Okay, there's a 5 near the beginning of the array. Okay. Okay. Now the array's got a 5 near the beginning. So let's see what happens when we step through there. Okay. Now start at 0, I equals 0. Look at slot 0. When I is 0, we're not to the end of the array and we don't find what we want. We just stay at line 26. Okay. Actually, let me go back and to see where we are, let's do this kind of trick here. Let's break the loop up into 3 lines. So we can see when we're on this line, and this line. Okay, notice that these are 3 different things here. I don't know if we break these up, there's 2 steps here, but if you break that up, I don't think Java will show those as 2 separate steps. I don't think the visualizer will show it as checking this and checking this. It does this as one. I'm almost positive it does that as 1 step. We'll check, but I'm pretty positive it does that as 1 step. It doesn't do it. It is actually 2 steps. Check this and check that, but I don't think it shows it as 2 steps. But this is a step by itself. This should be a step by itself, and this should be a step by itself. Okay, so fill the array. Oh, let's do it over again because there's a 5 right at the beginning. So that's 2. I don't want a 5 right at the beginning. Okay, there's a 5 in the middle. Okay, so let's watch how this thing works. Okay, so now we filled the array. Okay, done filling the array. We're going to search for 5. There's the number we're looking for. Okay, now we enter the for loop. So first thing we do is we initialize I equals 0. Okay, so there's I equals 0. Okay, notice it skipped over line 28 because it's going to treat all of this as 1 line. Okay, that's what I thought it would do. It just skips over the 28 and thinks of 28 and 29 as 1 line. Okay, so it doesn't let us see, it doesn't see this as 2 steps. So now it's checking both those conditions and it's finding that I is less than the length, so that's true, and this is not 4 is not 5. So this thing is true. So it'll go down here, and now it ups I to 2, I to 1. Okay. Now it's going to go back and do this again. Okay. So now it's checking this thing, and they're both true. We're not at the end of the array, and we did not find what we're looking for. So we increment I. Okay. Okay. Then check again. Not what we're looking for. So increment I to 3. Notice that there's nothing in here. We never go to the body of the for loop. The body of the for loop is empty. There's nothing in it. So we're just staying up here in this line here. We're staying up in this thing. So I is 3. Now I is 4. Now we increment I to 5. Okay, so now we're about to look at that slot there. Okay, so go forward. Now this is true, but this is false because it says random ints I, which is I of 5 is 5, that is equal to n. So this thing is false. So we're not going to go to there. We're going to go to line 34 now. So now we're going to go to line, see, 34. So this thing was false. So we jump forward to line 34. See? Now we don't need to adjust our answer. I holds where we found the 5. We didn't reach the end of the array, so we don't have to do the adjustment. Okay, and we print the answer. The index of 5 is 5. Okay? All right, so there's a funny way of doing it. Okay? So if I want, I should actually, I'll put this. It didn't do any good to put that on the line by itself. So leave it like that. Okay? So the for loop does all the work. This is a quirky kind of piece of code. All the work happens there, and you actually have an empty for loop. Every once in a while, people really write code like this in the real world. Just a quirky trick. Okay, but we're seeing that there's lots of ways of getting this code to do what we want to do. Over here, there's essentially 4, and you could write more than these 4. You could write more than 4 ways of searching an array until you found what you're looking for. Okay, there's more than one. There's more than 4 ways to do this, and all of them now they all do the same thing. They give you the answer of -1 when they don't find the first entry, or except for the first one. This one finds the last entry, and then the others find the first entry, and first, and they return, well, these two return -1. This one right now actually prints 2 different messages. So instead of reporting -1, it returns 2 different messages. So it's just that's another way to do it. You could print one message when you did find the number. You could print out a different message when you didn't find it. But that's actually printing messages. That's not giving an answer. Remember, if we think in terms of a function, see, we really should think in terms of a function like index of. We want to give an answer, a return value, not print an answer. We really want to have an answer that we can return as a function. Okay, so in a sense, all of these should be turned into this would be better off if we actually made all of these of functions, and the function should return the index, not print it out. So this is actually not a good way to do it. We're printing the answer. See, all of these we're printing the answer. The really better way to do it is to make each of these its own function, and the function would return the answer. In this case, it would return where. This one will return I. This one would return I. So they should return the answer, not print the answer. Okay. All right. So there's a bunch of examples of searching an array, doing this essentially the same idea as what index of does. Okay. Practice, it's really practice in writing for loops, lots of different ways. You notice how many different ways, there's different ways of doing the same thing. Okay. Now, okay, that's kind of this is a real famous example. Searching is actually one of the most important things that you can do in computer science. You look up things all the time in databases. So you can think of this as searching or looking up. You're looking up this number in the array. Okay, so it's like looking up a word in a dictionary. Are you looking for a word in a dictionary? You look up an employee in a database. You look up a customer in a database. You search the database for a customer to see if they're in the database. So this is a ubiquitous kind of problem to solve, and this is one way to do it. There are much more sophisticated ways to do this eventually. For example, this is what we call a linear search. It steps through the whole array looking for what it's looking for. Okay, so if the array has 1 billion items in it, it starts at entry 0, and it steps through the whole array until it gets to either the item it's looking for or it reaches the end of the array. Turns out there are more sophisticated ways to do this that don't necessarily have to look at every entry in the array. Okay, but you have to, for example, if you sort the array, if you have the array sorted, you might not need to look through every entry in the array. because if the numbers in the array in increasing order, you could pretty much start. One thing is you could do is start in the middle. If the numbers in the array are in order, like you've sorted all the suppose you have an array of customers and you've put them in alphabetical order, okay, and then you look for a customer. Well, just look at the middle item. If the customer name you want comes after that middle item, you can throw away the whole first half of the array. Okay, you don't have to start at the A. So if you're looking for a customer whose name begins with P, why would you start with the names that begin with letter A? You can kind of just immediately jump to the P's in a certain sense, or at least jump to the middle of the array. So if you're willing to spend the time to keep your data sorted, you can search in a lot faster way. But then you have to spend the time to keep the data sorted. So you still have to spend some time keeping the data sorted. So like over here, after we filled this array with random numbers, we could have put a step in the middle here of sorting the array, putting them in order, then looking for the number, okay? But then the answer would be the index in the sorted array, not the index in the original array. Now, maybe that's okay for us. Maybe we just want to know, did we find the random number did we find the number we're looking for? Or do we really want to know where it is in the original array? If we want to know where it is in the original array, then it doesn't do us any good to sort the array. Okay, so there's lots of ways of describing these problems. Do I just want to know, is the number if I generate 1 billion random numbers here, and then I want to know if the number 5 is in there, do I want to know where it is in there, or do I just want to know if it's in there or not? So depending on all these little extra conditions, I could write the code in lots of ways. And eventually, when you take the more advanced programming classes, you start talking about all these more sophisticated ways of searching for an array. Okay. Now let's turn to a different idea. We didn't write these as functions, okay? But they could have been written as functions. Here I just wrote them, like if we go back over here, I just wrote, here's one way to search the array, here's another way to search the array. So all the code is right there, one after another. Search the array 4 different ways. But I could have made those as functions, but then the functions have to take an array as input. So let's start talking about what it means to have a function that takes an array as an input parameter. Okay, so what I have here is here's a example file. We're going to spend a little bit of time studying this here. What this file has, it's like a library of functions. It's got, here's the table of contents of the library. It's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 functions. So there's a library of 10 functions. The function max, now I wrote it so you can kind of make it easier to compare here. Here's what the functions take in, here's what the functions return. So max takes in an array and gives us back an integer, which is the largest integer in the array. Min takes in an array and gives us back an integer, which is the minimum number in the array. Okay. Now look at this one. I call it ink in place. It takes in an array, okay, and it doesn't give us back any answer. What it does is it takes this array and adds 1 to every number in it. So it increments the array. You increment the array in place. I mean, you give it this array, and each number in that array gets 1 added to it. So the function doesn't give us back an answer. It modifies what we give it as input. We give it this as input, and when the array is done, this thing has been changed. Now compare that to this one. This ink array takes an array as input and gives us back an array. It doesn't change this one, but it does add 1 to, so what it does is essentially it copies everything from this array into the output array, but adds 1 to it. So as it's copying from this array to the output array, it adds 1 to every number in the input array. So these are 2 different ways of doing something we call ink array. We can ink array in place. You give me an array and I change what's in it. I add 1 to everything that's in the array. Or maybe you don't want this array modified. Maybe you need to keep it the way it is. So then I give you back a second array that has everything in this array incremented by 1. And that all the new data is in that array. We'll see in a minute what this one does. This one, notice that this one took in an array and didn't give me back anything. This one takes in an array and gives me back the answer here. This one takes in an array and gives me back the answer, but it's not the same thing as this one. There's something a little bit different about it. Notice it has the same idea. You give me an input array. I'll add 1 to every number and put the results in an output array. But this one says inc array chain. We'll see what that means. There's something called chaining, which is an important kind of idea in a lot of programming. Okay. And then this one, here's another version of inc array. Okay. What it's going to do is it's going to take in 2 arrays. And what it's going to do is it's going to treat this as an input array and treat this as an output array. It's going to take the data in this array, add 1 to it, and store the results in that array. It's going to erase what's in this array and replace it with everything in this array incremented. Okay? All right. So it takes that as the input. In a sense, it's taking this as input, but it's going to throw away the data from in there, replace the data that's in this array with everything in this array added with 1 added to it. But then what's this number over here doing? See, there's some return value that's an integer. We'll see when we get to that there's a reason for this number here. This number here is going to be, essentially, it's going to be reporting whether there was a mistake or not. It would be a mistake if these 2 arrays don't have the same length. If somebody goofed up and called this function with an array of length 100 here and an array of length 50 here, there's not enough room in this array to copy all these numbers into it. So that would be a mistake. So this thing will report a number. This also could have been a Boolean for true or false to say that, yes, it worked, or no, it didn't work. So this will be used to report the fact that something went wrong. Okay, so I could have been a Boolean, true or false. True for it succeeded in copying the data from here into here, or false, meaning, well, there's something wrong. This thing that would be wrong with this array and this array weren't the right lengths. They weren't the same length. Okay, then here's a search like we did before. Okay, what array to search for, what number to look for, and then the return value would be the index of where you found it. So this would be like the index of in the string. Okay, now, so we'll do these on Thursday. Okay, there's a lot of important patterns in this file. This is a bunch of ways of writing methods that use arrays. So the point of this example, it's kind of long. It shows a lot of ways of working with a combination of methods and arrays. Okay, so the combination of methods with arrays. Arrays is input, arrays is output. Okay, so these methods, like here's one that has no array input but has an array output. This one has array in and array out. This one has array in but only int out. This one has 2 arrays in, but we know that one of them, I just said that one of them is actually really an output array. Okay, this one's an input array and this one's an output array. So there's a whole bunch of different things going on here. It's actually this is like a little dictionary. This file ends up being kind of a dictionary of all the things you could do with how you can combine methods with arrays. Okay, and they're actually important tricks. This little dictionary of different ways of treating arrays and methods are ubiquitous in programming. If anyone's going to write a method involving an array, they're going to write it one of these 10 ways. And there's a bunch of different ways of handling arrays within methods. Okay, so these end up being like little patterns that you see over and over again. Okay, so that's what we'll do on Thursday. That's the last thing we'll do with arrays is these ways of treating a combination of arrays and methods. Okay, and then I'll put a reading assignment up for the next topic that we're going to talk about. So we'll finish arrays on, we'll be finishing arrays on Thursday, and then we'll start a new topic. Okay, anybody got any last second question? Okay, so we'll finish arrays on Thursday, and then And I'll take all Thursday because there's a lot in this last example. There's a lot of ideas in this example. So I'll put these up on the website. So I'll put this example and the ones we did today up on the website, and then we'll do this one on Wednesday. Okay, so see you, I'm sorry, on Thursday. So see you on Thursday. Bye.